Hi, hello everyone. Here I'm Mr. Wong. Here I'll be recording video to complete all the work examples in the NA wave notes. Okay, so now at any point in time, if it's too fast, please slow down the video yourself, or you can choose to pause the video if you wish to look at the answer for a longer period of time. Alright, please look at the first work example 1, explain what is meant by a wave. Okay, so this is just a pure definition question, right? A wave is just something that cause a or it starts from a disturbance, okay, and transfer energy without the matter, right? Answer is as such. Okay, disturbance that propagates through space, transferring energy but not matter. So these are the key points. Please take note. Then, of course, describe how a woman can produce a wave. Since it's a description, right? It needs to be more than a one-liner. So please make sure your answer cannot just be something like pulling the rope up and down. That's all. Okay, you need to describe. So, based on this answer, right? Pulling the rope upwards and downwards in a periodic motion. Okay, and then the particles nearest to her will pull the adjacent particles and then produce a transverse wave that transfer energy. Okay, so again, please pause the video yourself to look at the answers. Okay, if not, gonna go on to the next example question. Right, work example 2, explain what is meant by a transverse and a longitudinal. Right, so at this point you should have some idea of what transverse is and what longitudinal is, right? I'm pretty sure you should have this in your mind, right? Perpendicular for transverse, then parallel for longitudinal. But of course, you can't just tell me that, oh, it's a perpendicular wave, because what is a perpendicular wave? What is it perpendicular to? Right? You must state it very clearly. Then same thing for longitudinal. You can't just state that it's parallel. What is it parallel to? So in this case, transverse wave, right? Direction of vibration. Now over here, you might want to add on particles vibration. That is perpendicular to direction of wave travel. So same thing for longitudinal wave that has a direction of particles vibration. Okay, then of course, two examples, light or wave on a rope. Therefore, longitudinal can be sound or some form of seismic wave. Okay, so you're not required to know the exact type, but there are some types of seismic wave that are longitudinal, some are transverse. Okay, for example 3, define what is the wavelength of a wave. Right, what is the wavelength? Okay, wavelength is the shortest distance between two successive crests or trough. Okay, so the word successive is a keyword because only between, let's say, if I have this wave. Okay, let's say I have a wave that goes like this, right? These are the crests, these are the crests as well. These are the crests as well. So only between this and this crest, then we say that this is the wavelength, right? If you are just saying between two crests, right? It could be any random crest. So it could be this crest and this crest. Now in this case, this is not the wavelength, right? This is 2 lambda, 2 wavelengths. So the word successive is very important to define which crest that we should take note of. Okay, then afterwards, if you are talking about what is the wavelength, all we have to do is just to notice, right, one complete pattern, right, or one complete oscillation in a graph, right? This is called a displacement distance graph. Since the x-axis is distance, it tells us the wavelength. So in this case, right, you can draw it out. What is one complete pattern in this case? Okay, this will be a complete pattern, and in this case, the wavelength will be 15 cm. Right. What example for what is the period and frequency? So if you look at the graph just now, the difference between the previous one and the current graph is that you will see that the x-axis, this is time. So if this is a time scale, I can't read a distance, right? I can't read any distance from this graph. So all I can read is time. In this case, I can read what the period is. Okay, so also one more thing, if the question is asking you what is the period and frequency of the wave, now it's not asking you to define the definition of period or frequency. If they wanted you to define, they would say state, uh, or they will just ask you to define what is the period or define what is the frequency. Okay, if not, this is asking you for a number, right? Give a number, right? Reading from the graph. So period is when the shortest amount of time, oh sorry, not shortest amount of time, the amount of time taken for one complete oscillation. So in this case, I'll mark out what is one complete oscillation based on this pattern. So since I can see that at this mark is 0.6, so the period, if you recall, capital T stands for period, right? Small letter f stands for frequency. So period in this case is 0.6 second. Frequency is 1 over t. So 1 divided by 0.6, right? That should give you 1.67 hertz. Okay, capital H, small letter z. 1.67 to the 3SF. Now take note that this is not the wavelength, right? Even though it's a length. Remember that this is always the y-axis is always the displacement. So this gives me the amplitude of the wave, how far each particle can go from their resting position. Okay, leave it for another 5 seconds before we move off. If you need more time, please don't hesitate to pause. Alright, for example 5, a seismic wave produced by an earthquake has a speed of 7.2 km per second and a frequency of 30 Hz. calculate the wavelength. So, oh, by the way, calculate in meters. So maybe first, let's just use whatever values we have and decipher. Okay, we have the speed of the wave, and a frequency. Now we need to find lambda. Now looking at all these variables, are you able to come up with a formula, right, that consists of these three variables? Right, so in the back at the back of your mind, you should think of this: V equals to F lambda, right? This is the formula that links the speed of a wave with the frequency and its wavelength. In this case, if V equals to F lambda, I want to find what's my lambda. I will take V divided by F, right? Simple algebra manipulation. I want to make this my subject, so I need to shift this over to the other side, which means I need to divide both sides by F. So in this case, 7.2 km per second divided by 30 hertz. Okay, so what's the value? That gives me 0.24. Now what do you think will be the unit for a length, for the lambda here? Right? So if you notice that, oh, it has a km per second. Right, as compared to meter per second, that is the SI unit. So my resulting unit here for lambda will be in km as well. Okay, will be in km as well. And 0.2 km, since I need to leave it in meters, this is equivalent to 0.24 times 1000, right? Since kilo stands for 1000. So 1, 2, 3, 240 meters. Okay, of course, if you are more comfortable with inputting the numbers first, that's fine as well, right? 7.2 km per second equals to 30 hertz times lambda. And after that, lambda equals to 7.2 divided by 30. Right? If you prefer this, that is fine as well. You should get the same answer of 240 meters.